Hi, welcome to this video on Chapter 5 on the noble gas shortcut. The noble gas shortcut is an abbreviated electron configuration so that we can get rid of the portions of the electron configuration that remain the same and view the electron configurations of the valence energy levels, which is the outermost energy levels. The reason we only care about the valence electrons and we would use the noble gas shortcut is because those are the electrons that are going to be available when we talk about bonding. So first thing we want to talk about is the noble gas electron configuration for arsenic. So let's review. I'm going to go ahead and draw the configuration for arsenic. Arsenic is symbol AS and has 33 electrons. So when I'm looking at the configuration, if I was going to do the full noble gas configuration, it would be 1s, 2, 2s, 2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3. Now, looking at this electron configuration, the noble gas configuration, or not the noble gas, the valence electrons are the ones that are located in the highest energy level, which is your energy level 4. As we can see, is the highest energy level we have. And so that's also going to include your Ds. You can't just throw those away because they are a little bit higher energy than the 4. But what you can see is that anything below the 4s2 is really stuff that we don't care about. What we really care about are these 2 s electrons and these 3 p electrons, which gives arsenic 5 valence electrons. So what we want to do is depict the configuration only for the noble gas portion, or the valence electrons themselves. So that means that what I put in brackets right here, all of this, actually we don't need. But we can't just leave it off, because if we leave it off, that means it doesn't exist. And it does actually exist. Those electrons still need to be mapped. But we don't need to indicate them and write it out the long way. So what we do is we look on our periodic table at something, whatever has the electron configuration, basically of 3s2, 3p6. And so when we look at our periodic table, let me get there 1 second. When we look at our periodic table, what we can see is that the, let's see, where is it? The 1s2, 2s2, 2p6, 3s2, 3p6 gets us to argon. So hopefully you can see, I'm trying to circle over here, argon. Argon would be the noble gas that fits all of that area of electron configuration that we were discussing. So when I look at the argon, that's what would fit into that area that we were just looking at. So let's see. So if I was setting this up and I wanted to write the noble gas configuration, I would put brackets and put AR. That represents everything that I had in brackets. That is the configuration for argon. And then I would just continue on after those brackets with the remaining portion of my noble gas configuration, which is 4s2, 3d10, 4p3. So what this does is it shortcuts and counts everything from the noble gas before our element. It counts all that by putting it in brackets as the noble gas, and then we only have to write the valence energy level. Now, one thing to be important is you must depict the valence electrons. So you always have to do the entire final energy level. You can't skip ahead in this. So this only works for the noble gases. So you can only use a noble gas as a shortcut. So take a second and pause me, and then put it back on and check yourself with each additional one. And so take a second, go ahead and pause. And go ahead and try. Now check yourself to see how you did. So if I was going to do chlorine, chlorine's noble gas configuration would be brackets neon, because that's the noble gas before it. And then I would have 3s2, 3p5. So this shows me that only the last energy level of chlorine. All right, pause me and try calcium. Okay, so if you've tried calcium at this point, calcium would be in brackets the noble gas that comes before it, which is argon. And then it's just going to be 4s2. So that depicts only the valence electrons and uses a noble gas as the shortcut. All right, pause me again and try gold. All right, for the noble gas configuration of gold, you would use, keep in mind gold symbol is Au, and you would use the noble gas that comes before that, which is xenon, Xe, and then it's going to be 6s2. Don't forget your F's come right there, so it'll be 4f14, and then it'll be 5d, and in this case it's going to be 5d9. So that shows that with gold, really there's only 2 valence electrons. But remember, anything that's in the 9 likes to steal, so there's that weird exception here, that we could also write this as an alternative, where you could show that one of these electrons goes over here. So you could also write it as 6s1, 4f14, 5d10. So gold is special and actually has 2 configurations because the D's like to be full, and sometimes they'll steal from that outer energy level to make themselves full. This is also why gold can have a +1 or a +2 electron charge on it, which we'll talk about later. All right, and so you go ahead and try zinc, pause me, and then turn it back on and check to see your answers. Okay, if you did zinc correctly, you should have Ar, and then 4s2, 3d10. So again, zinc can only have a +2 charge, which we're going to talk about later in the year, but it only has 2 valence electrons. All right, so that is how to do the noble gas configurations. Please go ahead and make sure you complete the check for understanding questions below before you come to class, and bring with us any questions that you might have.